we have this problem, okay? We have a ring that has a distributed charge, and we want to find the electric field at a point on the z-axis. So we want to take a small piece of the ring with a charge dq. So the electric field produced by the small piece is dE equals to k dq over r square. And the distance to the point is r equals to z square plus r square. Okay? Z. So, because of the symmetry, the x and y components cancel out, and only the z component remains. So we use dE, dE in this case, dEz equals to dE cosine of theta. And the cosine is z over r. Now we substitute it, which give us the EZ equals to k dq over r square times z over r. And if we make the multiplication, is k dqz over z square plus r square 3 2. Why? Because here we have that it's the a square root, and in power terms it's written as 3 over 2. So this is just the same as this, or 3. Now we want to substitute dq. So we use the linear charge density with lambda. And it's lambda equals q over L, and also is dq equals lambda ds. This means that dE dEz equals k k kz times lambda ds over just the same, z squared plus r squared 3 2. Okay, so now we integrate over the whole thing, so it's ez equals integration of d e z. Okay, so ez equals all this. Gonna duplicate it. Ay. But we are going to raise ds because that's what it's going to be integrated. So it's integrate ds. Okay. Now the integral of ds is the total length of the ring. So the integral of ds equals to pr, which means we can put it in the final expression. So E is equals to kc lambda 2pr over c squared plus r squared 3 2. And now we know that q is equals to lambda 2pr. So easily we got kzq over c squared plus r squared 3 2. And now we're gonna substitute the values to get the final answer. So the value of k, it's the constant. 9 times 10 to the 9th z 1.5 q 24 times 10 to the minus 9c over 1.5 square plus r 3 square 3.5. We're just gonna put in the center. And now we just plug it on the calculator. One sec. And it gives us 8.59. See. Okay. And in a vector form that I think it's not they don't ask us that, but just in case. In a vector form, we have that in the x and y axis, it's 0. So it's gonna be 0, 0, comma, well, 0, comma, 0, comma, 8.59. Vector form 0, comma, 0, comma, 8.59. And see. And this is our final result.